import the matplotlib so we can plot everything, and then this would fit with the decomposition. So we were taking the data from the genres of the training sets and trying to figure out what the proportion was for the training sets of country and hip hop or country and other, and how it would be compared to the testing set.
Yeah, and that was the idea of the multi-layered bar chart, because it would be able to display the it would be able to best display the proportion of the number of country songs as compared to the number of other songs being hip hop. And that was the best way to visualize that, I suppose.
Yeah, and the visualization would be these lines. So we're plotting one bar for non-country songs, and then another one for country songs.
Oh, those are the labels, I believe. Oh no,
Yeah.
they are.
Yeah.
Yeah. Okay, I see what you meant.
And then this was one of the givens for us to have for the next question was, to create a two featured. So we would have to use this to plot, and I think, yeah, right here. This is where we had to plot and use the given, I guess, algorithm of one of the four pillars, so we could classify the genre with the color according to its genre on the plot. And so we had to create a like feature, and that was the x-axis, with the love feature, which was a y-axis, and then compute the number of times it says those words in a given song. And so we did a for loop for the song, whichever song it was looping, and in training songs, which is one of the parts. And then when it loops, when it goes through each part, it counts the number of like, love, and then for the genre it goes back to the original data frame and goes to the title of the song, looks for the genre, and then has the values, and then the genre color is given in this variable, and then we plot the color for the genre, and then the label is for the songs, and then that was for uh, the test songs, and then this is for the the training song is in the for loop, so you can use different songs, and then the test song is outside, so you can see where it is plotted compared to the other training songs. So we did this with 2 training songs, 1 test song, and then we did with 3 training songs and 1 test song, and then we found which one was closer. And then we had to find the distance between each song, so we had to use to find the distance between each song. So we had to do the y value and the x value, which was the distance in the x direction and distance in the y direction compared to the closest song. Sorry. So that's what we did right here. And then we had to find the closest song over the whole testing set, or we did the 7 closest songs over the whole testing set, and we had to plot a data frame. So we have the title, artist, the genre it was in, the number of times it said like and love, since those 2 were the 2 features we used to find the distance, and then we have the distance labeled so we can properly see that.
Yeah, and then that's just like the prerequisite to the k nearest algorithm idea, because like it doesn't have any of the like calculations or larger base comparisons of the later parts, but it does find the 7 most significant values that could later be compared to determine the genre of something, like in the k nearest neighbors algorithm.
Yeah, and then 2.5 we had to create another algorithm to find which one was the most common genre type compared to the distance, the nearest distances, the 7 nearest distances. and we came up with hip hop, which you can count them and verify that hip hop was indeed the most common genre.
Which is like the idea of classification, just by stating what's the most common of those 7.
Yes.
Selected as significant values.
Yes.
And then with 3.1, which one was this? Oh, this was just a very basic, well, it's the distance function for having multiple values at once. So whereas just x and y were compared above, this is comparing multiple points, or it's capable of comparing multiple points in the same data set. So like it can compute multiple features, distances in multiple dimensions in that way, so that more can be considered rather than just 2 values that those data charts were able to apply.
Yes. And then 3.2, so we had to create, and this is where it goes back to using the multiple data points. So we had to create 20 words. So you, instead of comparing 2 data points, we compared 20 data points and found the distance in between each data point.
Yeah, it technically didn't say to like code something. It just said like find 20 words that you think will work well. But like there were so many words to consider in that we wrote up a program that would find the most significant differences in the mean ratios for each word. And that would be the mean of every song for each word based on the genre it's in. And that difference was then sorted so that we could choose the top 20 with the largest distances, so that we could like choose actually important words instead of just random ones out of the thousands of words that we had options for.
Yeah. Let's see. It said 3.3 is the one he just discussed.
Oh, yeah.
3.4. So this was where we had to find the genre and the distance between each song and the training lyrics that we created in, I believe it was like 1.3, where we had to create a testing and training set.
Yeah, it's just calling upon the previous function along with like reworking the data frame to fit just genre and distance in there.
Yes. So now this is, so 3.4 goes into 3.5 and 3.6, where we had to create an algorithm to find the nearest neighbors. So 3.5 is used to find the genre of the 5 nearest neighbors of a close song. And 3.6 is the actual algorithm to find the genre of a test song using the 20 words that we found or that we decided to use. And then 3.7 is where it shows that we used a training or another test song, but instead of 5 neighbors, we used 9 neighbors to find the classify genre.
The best way that we were able to figure out to create an algorithm that could do this for multiple like individual songs in this way is to have the what are they called? The features basically include the song name, because otherwise it's going to try to compare everything to everything, and it just doesn't work like that. So the best way we were able to do that is to have it account for the last part of the test list to be the song name, which was added in there. You can't see it on here, but it's there. And then it would select the actual features to be everything but that last name, basically.
Yeah. So 3.8 is another decomposition factor. So we had to create a new test set from the original test set. So we did that with selecting 20 and then resetting the index.
And that was basically so that the algorithm could run faster, because when you're comparing everything in a test, like in that huge test set, to like 20 different features, then it would take way too long for it to really function well.
Yeah.
How long has it been?
For the data frame that we printed?
The video.
The video? It doesn't tell me, but it's been almost 10 minutes already, so it's going to be
Okay,
over 10
just
minutes.
then talk about the 5.2.
Okay. So we did. How did you work as a team to complete the project? So we each tried to do one section by ourselves to help each other out, but Lucas ended up doing a lot of it because I was having trouble um, with my sections. But we did try to do our parts separately, but ended up helping each other out where it was necessary to complete the project.
Yeah, for like time purposes, obviously we allotted sections so that you know, because we couldn't meet up all the time, so that was unrealistic. But like a lot of the time during those sections, we would ask for each other's help or get an input on something or have something fixed by the other so that it would work more smoothly and so that we could actually like complete a section without running into the same problem over and over again.
Yeah, and to try to complete the project too, we both went to like the tutoring sessions to try to get help from the teachers too, just in case both of us couldn't figure out the problem. So we went to the tutoring sessions, and our TA was very helpful with helping us out with our problems.